Real number system and Cartesian coordinate plane. Some definitions. Variable is a symbol that can vary in value. Constant is a symbol that does not vary in value. Expression is a mathematical relationship that does not contain an equal sign. Equation is a mathematical relationship that does contain an equal sign. Inequality is a mathematical relationship that contains an inequality symbol. Could be not equal to, less than, or less than equal to, or greater than equal to. Absolute value of a number is its distance from zero on the number line. Set is collection of objects. Set notation. Set is denoted by using curly parentheses, and its elements are included inside the curly parentheses. Natural numbers, set of natural numbers is all the counting numbers, 1, 2, 3, 4, and so on, all the way to infinity. Whole numbers are all the natural numbers, including 0. 0, 1, 2, 3, and so on are whole numbers. Integers are positive and negative natural numbers, as well as 0. Rational numbers is a real number that can be expressed as a ratio of integers. Irrational numbers are any numbers that is not a rational number. They would be irrational numbers. They are non-terminating and non-repeating decimals. Real numbers, all numbers that can be written on the number line, are real numbers. Ways to write a set. We can express a set in the roster form, or we can express a set in the set builder form. So two different ways of expressing the set: roster form and set builder form. We can also express a set in interval notation. So if you're given a set in the set builder form, x such that, this line is read as such that, x such that x lies between a and b. We don't have any equal signs. That means we're going to be using either open dots or open parentheses, and x lies between a and b. So all the possible values of x lie between a and b. We could use open dots or open parentheses. Next example, x such that x is less than equal to a, or x is greater than b. Less than equal to a are all the numbers on the left of a. Numbers less than a, so we have to use close bracket here or close dot. And x greater than b, there's no equal sign there, so that would go to the right side of the b on the number line. And we can use open dot or open parentheses. Recall that the rational numbers can be written as quotient of two integers with or fraction. So they can be a terminating or repeating decimal. So all these are examples of rational numbers because they can be expressed as a fraction using two integers, where numerator and denominator are both integers. Irrational numbers can be written as decimals that do not terminate or repeat. They cannot be written as quotient of two integers. If a whole number is not a perfect square, then its square root is an irrational number. For example, 2 is not a perfect square. Square root of 2 is an irrational number because square root of 2 is non-terminating, non-repeating decimal. And your calculator may not show repeating decimals because it only shows the limited number of digits. Next, here's a Venn diagram showing all the real numbers. So the smallest real numbers consist of rational and irrational numbers. Irrational numbers are non-terminating, non-repeating decimals. Rational numbers include natural numbers, whole numbers, and integers in them, because all those can be expressed as a ratio of two integers. Classify the real numbers. So square root of 5, if we use a calculator to find square root of 5, this is going to be a non-terminating, non-repeating decimal. So it's irrational and it's real. It's not a whole number, not a natural number, not a rational number. So irrational and real. Negative 12.75. Negative 12.75 terminates at a point. So this is rational and real. It's not a whole number, not an integer, not a natural number. Square root of 6 over 2 is 4 divided by 2, which is equal to 2. This one is a natural number. This one is a whole number. natural number, whole number, and integer. It's also an integer. It's also real integer. It's a real number, and it's also a rational number. Because we can express 2 as 2 over 1. We can express it as a ratio of two integers. Division with 0. Dividing any number k with 0. So if we divide a number k with 0, that is undefined. Division with 0 is not possible. And dividing 0 with any number k is always going to be 0. So remember, k over AO knock out. So dividing any number k over 0 is knock out, it's undefined. And dividing any number 0 over k is okay. It's still going to be 0, still a real number. For example, 5 divided by 0 is undefined. And 0 divided by 5 is equal to 0. Properties of real numbers. First property we're going to discuss is commutative property. Commutative property, just like the when we commute, if I go from my house to college or college to my house, the distance does not change. So commutative property says the order does not matter. Commutative property of addition, a plus b equals b plus a. For commutative multiplication, a times b equals b times a. So when we multiply or when we add, the order makes no difference. Next, associative property. This property has something to do with the grouping symbols. When we are adding, place where we place the grouping symbols does not matter. Whether we place grouping symbols around first and second number or second and third number. Same thing, associative property of multiplication. When we multiply, we can put grouping symbols around first two numbers or last two numbers. Your answer is not going to change. 6 plus 4 plus 5 is equal to 6 plus 4 plus 5. Same way, 6 times 4 times 5 is equal to 6 times 4 times 5. Next property is distributive property. Earlier we saw commutative and associative properties. We had commutative of addition, associative of addition, commutative of multiplication, and associative of multiplication. But distributive property involves both addition and multiplication. So a times b plus c, the a gets distributed inside, turns out to be ab plus ac. If we have subtraction inside the parentheses, it would be ab minus ac. And we have examples of distributive property. Identity property. Identity property of addition is 0 is called additive identity. 0 is called additive identity. So any number plus 0 makes no difference. The number remains the same. A plus 0 is still going to be A. 1 is called multiplicative identity. So multiplying any number with 1 makes no difference. It's still going to be the same. Any number times 1 is still, a times 1 is still a. 6 times 1 is still 6. Negative 7 times 1 is still negative 7. Inverse properties. Inverse property of addition. So if a is added to its additive inverse, then the answer will be 0. Adding a number to its additive inverse will be 0. Multiplicative inverse property. If we multiply a number with its multiplicative inverse, that would be equal to 1, always. Rectangular or Cartesian coordinate system. So we have our quadrants. X, Y is intersection of X and Y axes is rectangular coordinate system. And we have quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So to plot the point A, which is 5, 3, we're going to look for 5 on the x-axis, 3 on the y-axis, and plot our dot. And it will be in quadrant 1, quadrant 2 here, quadrant 3, quadrant 4. That's all for this video.